Hi guys, this is Miss Eisencraft, and I'm here to go over the Unit 1 test review. So for the first one, for the triangle shown, suppose B is 10 and the angle B, the measure of angle B is 40 degrees. So let's make this 10. Let's make this 40 degrees. And the first thing says, find the value of A. Well, in reference to this angle, our 40 degrees, 10 is the opposite, and they're asking us for A, which is the adjacent. So opposite and adjacent is a tangent ratio. So we are going to write here the tangent of 40 degrees is equal to 10 over A. Now, when you're solving and the A is in the denominator, you're going to have some issues. You have a little extra step to do. So then we have A tangent of 40 equals 10. Then we're going to divide by tangent of 40. And grabbing a calculator, make sure you're in degrees. 10 divided by tangent of 40 is about 11.9. So A is about 11.9. And we can see right away this is not drawn to scale, but we don't worry about it. The next step, find the value of B. So here's a little error because B was already given. It was because I cut and pasted this from another example. So just for fun, let's see if we could figure out C. So I want to just still use trig ratios, even though I could possibly use Pythagorean theorem. We have the 40 degrees, and let's continue to use B because it's a nice number. We know the opposite. Now we're looking for the hypotenuse because C is the hypotenuse. So opposite over hypotenuse is a sine ratio. So we're going to say sine of 40 degrees needs to equal 10 over h. Again, our variables in the denominator, which is a little bit of a pain. Okay, so then we have, let's go over here. We have sine h sine of 40 equals 10. I'm going to divide both sides by sine of 40. Make sure you are in degree mode. And divided by sine of 40 is about 15.6. So the length of C is about 15.6. Okay. Now, when it says find the measure of angle A, the triangle sum theorem tells you you have 180 degrees. So there is only 50 degrees left. You could also do some inverse. You could also do some inverse, side length ratios to get that angle as well. Okay, but 50 seems pretty easy. All right, now we're going to sketch each angle in standard position and list 3 coterminal angles. At least one of them needs to be negative. So we have 330 degrees, all righty. So I know this is 360, so 330 is, well, that was dumb. Right? Okay. Boop, boop. Whatever. Okay, so list 3 coterminal angles. So we would just add multiples of 360, but we do need to 330 plus 360, 690. Make sure I get down there. So here we go, 690, another 360, 1050. Coterminal means it would end at the same spot. It would and terminate at the same spot. Okay, but we also need a negative. So let's take the 330 and minus 360, negative 30 degrees. I could have. Okay. All right, next one, sketch the same angle and indicate the reference angle. So again, if we go to 330, that's here, right? And then the reference angle is you measure the terminal side to the horizontal axis, the shortest side, and that is a 30 degree. That should be right in the corner there. sketch the same angle and indicate the reference angle and give its value. The value is actually 30. Some people were thinking it meant you had to then use special right triangles and find these side lengths. You don't. But it's just saying if you have 330, the reference angle is the terminal side, the distance from the terminal side to the horizontal axis. All right, let's keep going. Sketch the reference triangle, labeling the side lengths, and list the cosine and sine values for this triangle. So here we go. This is weird. Okay. 5/4 pi 5/4 pi radians is, let's see what we've got going on here. You could just do the conversion, but sometimes we like to think of this in degrees so we understand it. But I know this is 0 radians. I know all the way over here is pi radians, like 1 pi radians. Okay. So this is pi halves. Half of a half is a fourth. So 5 pi fourths would be like right here in the middle. Okay. 5 pi fourths radians. Okay. Label the side lengths and list the cosine and sine values. So we're sketching also the reference triangle. So let's go ahead and go. Boop, boop. No, thank you. No, thank you. Let me see if I can just go like this. It just keeps selecting instead of using my pen, which is an issue with, right? Feeling your pain. I could have done this on paper, but I chose not to. Okay. There we go. So if you have 5 pi fourths, what's just this measurement right here? Okay, from the horizontal axis here. Well, if this is pi radians, there's only, pi fourths radians left right here. So the reference angle is pi fourths radians, which is in degrees, that's 45. So this is really a 45, 45, 90 degree triangle. And if you remember from special right triangles, like if I go here, right? When the hypotenuse is 1, when we're using a reference triangle with a hypotenuse of 1, the side lengths are √2/2 and √2/2. So if we go back, that means that these side lengths, √2/2, I don't know why, stupid pen, and let's try this. It's still jumping. Stupid pen. Okay, so why we care about that is because these side lengths are the cosine and sine values of this angle. Okay, so remember cosine is the x value and it's -√2 because you go to the left. And the cosine is down, so it's also -√2/2. So that's cosine, which really doesn't matter here because they're the same. Whatever. Why aren't you letting me write on my paper? There we go. Cosine, and that is sine. Okay. All right. Next, write a sine and cosine equation for the following graph. So the easiest thing I think to do is first identify the maximum. Oh, and this is kind of an annoying one, but we got it. We got it. Looks like it's 6.5. We're going to assume it's 6.5. Okay. And this is -2.5. So the distance between -2.5 and 6.5, right? 6.5. Oh, don't be confused. That's 9, isn't it? That's a distance of 9. 2.5 plus 6.5 is 9. So half of 9 is 4.5. So you're going to count 4.5 to the center. There's a half. 1, 2, 3, 4. Let's make sure that's right. Mr. Penn, I'm going to talk nice. Please let me write. Right? That's the whole purpose of you. I don't like you. Okay. And then a half. 1, 2, 3, 4. We are good. Okay, let's see why my pen isn't registering. Now it is. Thank you. Boopity 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 boop boopity boop boop. Okay, so there's my midline. Okay, that's helpful because the midline is used in the equation. So the midline is positive 2. That's easy. Okay. The amplitude is also used. The amplitude, it looks like we're going from 2 all the way to 6.5, right? Which is 4.5. So the amplitude, you guys, today is not my day with my stylus. Okay, 4.5. All right, so far so good. All right, now we need to know that fun little thing called B value. Okay. Yeah, B value. So here we go, B value. That's what you get when we have a video key. You get all my thoughts. I'm sorry. Boop. Censored for appropriateness. Okay. Which, it's because this is selected. Watch this. I wonder if I go like this. Watch this. Watch this. If I go, now will you let me write on it? Please. Yes, you will. You're the best. Okay. So the period, I like to mark the period from the top of the mountain to the top of the mountain. Okay. The period looks like it is 5 to 17. So the period is 12. That doesn't go in the equation. But what does go in the equation is 2 pi over 12. So if we go, you can leave it like that, or you could say pi 6 for fun, right? Because that's simplified. That is your B value. And the B value comes from taking 2 pi over the period. And the period wasn't that hard to find. Okay. So now we have to decide if we're going to use sine or cosine, and that will, our phase shift will depend on that. I think it's easiest to first look at cosine because cosine starts at the maximum. So if I do cosine, A goes in front, right? Then we have cosine. I want to cry. But I'm not going to. Cosine, okay. Then we have B. So I'm going to do pi 6. Don't forget your X. Now, it did move over. I'm going to look to the right. It looks like it moved over 5. And then it went up 2. My pen is halfway cooperating, which is more than halfway frustrating. Okay, next one, sine, boop, 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 halfway. What is your problem? Here's a great thing. For sine, it just means you have to look at where you begin. So that's going to affect your phase shift. So sine starts like on the midline, right? We're looking for the midline because normally sine does this business. I hate you. Why are you jumping? So we're looking for this spot. So we're looking at the midline, and when does the sine graph start heading up at the midline? Right here, right? So that looks like it shifted 2 to the right. So we're just going to do everything else. I am going to figure out why my pen is being so dumb. I did this once this summer, and I about lost my mind. All right, hope that helps, and I hope you enjoyed my frustration with my pen. Good luck, you guys.